All right, so now we're looking at the cosine function. So we're going to look at the cosine graph and then everything that comes from it. So what I did was I took all these values from the unit circle that was on the first page. And what we're doing is we're tracking the angle, which you notice in bold typed font there, and the values of cosine as we go. So notice it's a little bit of a different pattern than with sine, but there is going to be something that you notice once we get to the graph. So just some particulars. We also know that if two angles are coterminal, the value of the cosine is the same because that ratio is not going to change. So that means cosine of theta plus 2 pi is the same as cosine of theta. And that means for any angle that is coterminal to theta, a word we're more familiar with, the values of cosine are the same. So we have this whole repeating thing happening again, and that means that cosine has a period of 2 pi radians. So this is not unfamiliar territory for us here. So looking at the graph of cosine, now again, I'm going to put in a y-axis here to avoid confusion. And remember that cosine of 0 from the table above was 1. At pi over 2, we were at 0. At pi, we were at negative 1. 3 pi over 2, 0. 2 pi, 1. And then we repeat again. So what does the cosine look like? Well, it should look similar to sine, I would guess, because things oscillate. And there we go. And of course, naturally, graph of the cosine keeps going there. So there's what the graph of cosine looks like. Starts high, ends high. Between two highs, you have a low. And between a high and a low, you have an intercept. So those are going to be the key components of graphing cosine. So going right into it, what happens when you want to graph y equals 2 cosine of x? Well, same argument as before. We're taking the original cosine x and we're doubling the output. So that means that if my high point was 1, now it's going to be 2. So this graph is going to start at 0, 2. It's still going to zero out at the same place. And it's going to go down to negative 2 and back up to 0 and back up to 2. So there is what one period of cosine looks like. And I'm going to try my best to not butcher this too badly, but there we go. That's not so bad. Okay. So this means, if you want to use familiar vocabulary, this means that the amplitude is 2. Okay. Now let's look at another one. And again, combining ideas here. Notice there's a negative out front of the cosine x. So that means we're going to be reflecting. And cosine of 2x means that the period is 2 pi over 2, which is pi. So we have an inverted cosine graph that has a shorter period than it did before. So one more time, starting at 0, and the first period is going to end at pi. Now remember, cosine usually starts high, but since it's reflected, it's going to start low. And then it's going to go up and down and repeat itself by the time it hits pi units again. So one more time, halfway between two lows is going to be the high, and then there's an intercept in between. Here's what the graph of negative cosine of 2x looks like. If we need another period, we got it. There it is. Okay? And of course, it's going to keep repeating itself and keep repeating itself. So I'll just draw little arrowheads there. Okay? So again, we can still combine these ideas. Now, what if we have 1.5 cosine of pi x? Well, we know that the number in front is the amplitude. And we know that pi x means that the period is 2 pi over the coefficient, which is 2. So the period is 2, and the amplitude is 1.5. So let's see how that works out. Well, I'm just going to use each tick mark is 1 unit. So that means this is 1, this is 2, this is 3, this is 4. And I'm just going to use this right here as the y-axis. Why not, right? So if the amplitude is 1.5, now remember, normally the cosine starts at 1. This means that if I'm amplifying it, 1.5, that means I'm going to start at 1.5. And that means by the time I traverse 2 units, I'm back to 1.5 again. So here we go again. Halfway between the high points is the low point, and halfway between a high and a low is the intercept. And I'm going to repeat that pattern again. So here is 2 periods of this graph. I got a little bit off here. That shouldn't be there. I thought that looked a little weird. It should be here. There we go. There we are. So there's two periods of the 1.5 cosine pi x. All right. So when we come back, that summarizes graphing sine and cosine with only amplitude, reflecting, and period changes. What we're going to look at next, as you can see here, is horizontal shifting. And that is going to be a little bit more difficult, so that requires a whole new video. So please come back. Thanks for watching.